Alright, so today, learning goal is I can factor polynomials completely. And what that means is that when we are given a polynomial, sometimes when we factor that, we get two factors. One of those factors can also be factors. So it's basically like we're in Inception where we factor within a factor within a factor. Kind of is. So, to factor a polynomial completely, that's what it's here. After we've done factoring it once, we check to see if any of the new factors can also be factored. So over the past week, we've done 4 methods of factoring. Someone name me one.
Diamond.
Diamond method, that's one?
Foil.
No.
Oh wait, a
Square.
factory?
Box one.
No.
The one where you can take the square roots.
What's that called?
I forgot the name of
Perfect
it.
square.
What did we do yesterday?
Ooh,
Perfect square.
GCF.
GCF is one. What's another one?
None.
There's 2 more.
Difference of two squares.
There's another one.
Grouping.
Grouping, there's the last one. Alright, so, and for any polynomial, so any size polynomial, we can always look for a GCF. This is the most important one, so all our problems, the first thing we're going to do is going to look to see if there is a GCF that we can factor out. We might not always have one, but that's always the first thing that we look for. Next one, for polynomials with 4 terms, what did we do when we had those? We factored by grouping, so look for factoring by grouping. Number 3, when we have binomials, what we were doing yesterday. Luke Rand is the one who said it just now.
Difference of squares.
Difference of 2 squares, yep. And then the last one, when we have trinomials, what's the last method that we factored? That's multiplying.
Diamond.
What? You said foiling.
You did.
I did?
Yeah.
Like 10 minutes ago.
Alright, so when we're factoring, the first thing we always do is look to see if there's a GCF. Factor that out if there is one. After that, based on what kind of polynomial it is, try one of these methods. So, number 1, negative 3x cubed plus 27x. Always look for a GCF first. So can we factor out anything out of that one right away?
3x.
What is it?
3.
3x. And if we factor that out, what are we left with?
X squared plus 9 and 9.
What was it, Kara?
Negative x squared plus 9.
Negative x squared plus 9. So we found the GCF, that's good. Now we have a new factor, negative x squared plus 9. What kind of polynomial is that one? It's a binomial, so based on what we have up here in our notes, what should we be looking for? A difference of 2 squares. We have a binomial factor, so we should be looking for a difference of 2 squares. So right now, negative x squared plus 9, does that look like a difference of 2 squares?
Yes.
Really?
If you swap the 9 and
Right, it doesn't look like it this way, but if we rename it to 3x times 9, oops, minus x squared. We just flip-flop them, it would be 9 minus x squared, so is that a difference of 2 squares?
yes.
Sure is. So just like what we were doing yesterday, we square root our first term, square root the second term. So what is the square root of 9?
3.
What's the square root of x squared? X, that's right. So when we're factoring this part, we're gonna have two binomials times each other. What are they gonna start with? Nope. 3. They're gonna start with the square root of our first term. They're gonna end with the square root of our second term. One's addition, one's subtraction. Alright, so now we just bring everything down. We still have that 3x out in front, so. Oops, no, 3 does not go first. 3 plus x, 3 minus x. Alright. Think we're done?
I wish.
Well, the only way to find out is, now we have 2 more factors, right? It's like you check problems? No. So I'll probably say check a lot, and when I say check, I mean that whatever new factors we get, we have to check to see if we can factor them. So you don't have to do check problems. Everyone clear on that?
Yeah.
Okay. So, 2 new factors, 3 plus x, 3 minus x. What kind of polynomials are they? Binomials, so what should we be looking for? Difference of 2 squares. So, 3 plus x, is that a difference of 2 squares? No. First off, there's an addition sign in there, so we can throw that one out. 3 minus x, is 3 a perfect square? No, it's not, so that one's out too. So we can't factor anymore. So our final answer for this one would be 3x times 3 plus x times 3 minus x. So all we're doing is we're just combining all kinds of factoring that we've done so far.
You can use the next one's gonna be 5y.
All right, number 2. First thing we always do is find the GCF if there is one. So what is the greatest common factor that we can factor out of all 3 terms, Hunter? 5y. And what are we left with after we factor out in 5y? Hunter?
Y squared minus 4y plus 4.
All right. So we factored out the GCF, we have a new factor now. Y squared minus 4 plus 4. What kind of polynomial is that one? It's a trinomial, so what kind of factoring should we try out for it? Diamond method, that's right. No. Okay, one today. So when we have a trinomial, we always find 3 certain things. A, B, and C. A is 1, B is -4, C is 4. And once we have those found out, we get our diamond. What goes upstairs? A times C, but we can just put C.
So it's 4.
Right, since A is 1, we only have to put C upstairs. And what goes downstairs? -4. Alright, so now we're looking for 2 numbers that multiply to +4 and add to -4. Mara, -2 and -2. Alright, so when A is 1, after we find our diamond method, our 2 new factors are going to start with the square root of our first term. So what's the square root of y squared?
Y.
Y, so in our new binomial factors are both going to start with y. The 2 numbers we found are -2. So we have those. But remember, we still have this 5y up here that we always have to bring back down.
Wait, where'd you get the Y?
It's the first term of A, so you have to write that down.
Hmm?
How'd you get the Y in the parentheses?
How did I get this way?
Yeah.
That's what we started with.
Just remember
Why we have the y squared there?
Yeah.
So, if we were to FOIL this out, what would we get? What's y times y?
Wait, they're both negative what, too?
Yep. So if we FOIL this out, y times y is y squared, y times negative 2 is, and then negative 2 times y is, and then negative 2 times negative 2. Right, so they both have to be 1y.
I think we forgot to recognize that A was 1 this time, so that's why we could go directly to writing the factors. We've been also doing it when A is not equal to 1 and it's easy to get them mixed up. So when A is equal to 1, that's the easy one. Not as much work.
Alright, so we factored it, we have two new factors, y minus 2, y minus 2. We have to make sure that we can't. They're both binomials, so we would be looking for what kind of factoring?
Difference of 2 squared.
Difference of 2 squares, so is y a perfect square?
No.
No, it's not, so we can toss that one out. And we just have y minus 2 again, so we can toss that one out without having to check anything. So, we are done factoring here. And that would be our final answer. But, what's another way that you could write that? That might show up in an answer bank on a test.
And then
5 minus 6.
Y
Minus 2
2 squared.
squared.
So like that?
I think so.
Yep, that's exactly right. Alright. Any questions so far? Okay. Moving right along to the backside, number 3. First thing we always check for is if there is a GCF. So is there anything that we can factor out of all 3 terms? 1, right, we could always factor out a 1, but since we can't factor out anything else, we can say that there's no GCF for this one. So since there's no GCF, do you think we're done?
No.
No, we're not. What kind of polynomial is that? Trinomial, so we could still try to see if the diamond method would work for it. So trinomials, we always find our A, B, and C. A is 2, B is 11, C is 6. So get your diamond all set up. What goes upstairs? 12, A times C. What goes downstairs? 11. Alright, so we're looking for 2 numbers that multiply to 12 and add 11.
3 and 4.
Alright, so since I know that a lot of other students, this is the hardest part for them, finding the numbers. So one way that you can do this is, here we have 12.
Negative, 12 negative.
So what are pairs of numbers that multiply to 12?
1, 12, 6, 2, 3, 4.
1, 12, 2, 6, and
3, 4,
3, 4.
3, nothing.
Alright, so those are all numbers that would multiply to 12, right?
We can't have a negative one.
That aren't negative.
Then you change 12 into
So 1 plus 12, is that equal 11?
No.
No. 2 plus 6?
negative.
No. 3 plus 4?
No.
No. So,
She's busted.
based on that, there are no things that we can, or no numbers that we can factor it out to. We can say that this one is not factorable.
I think those-
Yeah. All right, number 4. You guys know what I'm gonna say? GCF, right. So what can we factor out of both terms in this one?
2.
Is it just 2?
4.
4x. We can take an x out of both sides too, right? So after we factor out the 2x, what are we left with?
49x squared.
Mm-hmm. Oops. And 25y squared. All right, did our DCF.
Now you're gonna do
Now we have a new factor, a binomial factor, so what kind of thing you guys look for?
square one.
Difference of 2 squares. So, is this a difference of 2 squares?
Yes.
Why?
Because of the
49
that's square root.
x squared.
They both have square root.
So if we square root both terms, what's the square root of 49x squared?
7x.
7x. Next one, 5x, or wait, nope, that'd be y, not x.
Okay.
Y squared. So it'll be 5y, right?
Yeah.
All right. So in a difference of squares, the 2 factors that we get, they're going to start with what and end with what for this problem?
We're gonna start with 2x, 7x, and then minus 5y. And then 2x would be on the outside, wouldn't it? So you gotta carry that.
Yep, so 2x, 7x plus 5y, 7x minus 5y. Bring that sucker down. Alright, so we've got one factor in that one. You have to check to see if we can factor anything else. Can we?
No.
Why?
Because
Why can't we factor 7x plus 5y? It's binomial and we're looking for difference of 2 squares. When we have binomials, that's addition, so that's out right away. 7x isn't a perfect square, right? So that one's out too. So our final answer would be what we have right here. And that's in the way of the next one. There we go. All right. Go through number 5
we're gonna do
together, then I'll let you guys do number 6. So you guys tell me how to do number 5.
take
I have amnesia, I don't know how to do anything.
3, 8 to the 4 out of each one, so like your GCF.
So we take our GCF out of everything, and
Yeah.
it's 3a to the 4th,
That
right?
would be 2a to the second, or 2a squared, minus a minus 3.
Right. So we found the GCF. What kind of polynomial do we get? Trinomial, so we're gonna use what? Right. And what do we always find in trinomials?
A, B, and C.
A, B, and C.
A, B, and C, right?
There's numbers in trinomials too. Yeah. Yes.
So what goes upstairs and what goes downstairs?
-6 upstairs, and then -1.
Okay. So 2 numbers that multiply to -6 and add -1. -3 and 2. -3 to, does it matter what side I put them on? No, it doesn't.
Okay, 2's gonna be your starting number. Wanna be 2 will be your starting number.
For what?
Parentheses, 2 minus 3 and
So here's a question, can we just bring those into parentheses right away?
2. Why not?
Exactly, why not?
I don't know.
When is the only time that we can go straight from that step to bring them into our binomial factors?
I don't know.
When A is 1, that's when we can take these numbers and put them straight into our factors. Is A 1 in here? No, it's not. So now we have to factor by grouping now, right?
How do you know that?
How do I know that?
Like amnesia.
I don't know.
Your grand.
It randomly came back to me.
It's a miracle.
That's a cool disease.
I know, right? 2A plus -3A plus -3.
Where are you getting 2A squared?
From before.
So we were just factoring this triangle right there. Yep. So we rewrite it as a fortune polynomial. Now we can start factoring by grouping, right?
Yeah, can't we also just like,
Totes.
what are we trying to solve?
We are trying to factor this thing all the way down to its simplest form.
So this is right.
No. The reason why is because A is not 1. The only time we can just take it is straight into the
Okay.
Alright, so 2A squared plus 2A, that's our first group. Plus -3A plus -3, that's our second one. Now I find the GCF of both groups now, right? What's the GCF of the first one? 2A, what are we left with? A plus 1. Second group, what can we take out?
3. -3.
We can take out a -3, and what are we left with? A plus 1. Now that we've got this far, they both have a common factor, and what do we do with those? We take it out in front,
And then
and what do we have for left over?
minus 2.
Then we have 2A minus 3.
For the whole day. So scared.
Alright, so we're done factoring there. Bring this one down, so we have 3A to the 4th times A plus 1 times 2A minus 3. Are we done factoring?
Yes.
Yeah, I'm done.
Yes.
I'm done. What are you guys?
Yes, we are. We have to check to see if we can factor any more.
You can.
New one. 2 new binomials, one's addition, so that's out. New one's 2A's in the perfect square, that's done, we're good. Alright, you guys. Do number 6 by yourselves.
Easy. I said I was.
It's quite hard.
I lied, I don't know what I'm doing. Can I just like, just a combo?
I'll start you guys off, I'll find the GCF for you.
So he's got this, guys.
There you go, that's the first step for you.
Oh my goodness.
Why?
Too many letters.
We're not.
That's your greatest one.
Alright. Wow.
This looks good.
Well.
Uh-oh.
So with why is this our option?
Hmm?
How are we doing?
Why are we doing
How
this?
do you do that? How do you do that?
First thing we do is find the GCF of the whole thing. Yep, just take an X and a Y out of both terms.
Hold on, am I done?
Sorry.
Then, some, they can plus.
You're right so far.
Did it say?
So what?
So am I done now?
Oh, do I have to do, oh, you slide on.
Oh, I see. Oh, now I know what to do. Am I wrong?
You're right so far.
There's more.
Yes, there is, and I figured it out. I figured out the numbers. Yeah, I get it right now.
No. Did I
I figured that all over again. Do that. You know, you can do that all over again. I did that. I did that all. Why can't
I will.
Uh,
He might be like a giant, but I would like to see.
So just leave that one square.
Where?
Did I get it right? What? Are you yanking my chain?
All right. See that no one is being on task with what they need to do, or at least some of you. All right, so first thing we did, find the GCF.
Yes.
Next thing we do, what kind of polynomial is that?
Oh, you gotta
Stop. And what is it?
It is a binomial,
It is
so
a
you need to
binomial.
find the difference of squares.
Right, so what is the square root of x to the fourth?
X to the second.
X squared, right?
But you can do it all over again.
Yeah.
It's just X.
So we do the square root of x to the fourth, that's x squared. Same thing with y to the fourth, that's y squared, right? So when we factor that out, we have x squared plus y squared. That's 1, and then the other one's x squared minus y squared.
Yes.
Is everyone good with that one so far?
Yes.
All right.
Buddy, you can take your notes.
Do you?
Well, I'm gonna teach. So I have it.
Oh. All right, so we just got done factoring that one.
You can do it again.
Now we have to see if we can factor anything else.
Now, square again.
So x squared plus y squared, can we factor that?
No.
No, because there's an addition sign, that's not fun. Next one, x squared minus y squared, can we factor that?
No.
Yeah.
You said I couldn't.
No, I said you could.
I did already know that.
So, for the next one, we take the square root of x squared. What's that?
X.
X, then the square root of y squared, what's that?
One.
Y. So when we get all done, we should have x squared plus y squared
Whoa, what did you do?
times x plus y times x minus y.
Whoa.
What?
Oh, you gotta add it in because, yeah.
What a.
I see it now.
Alright, so all that happened is at each step, first step we found the GCF, right? Then we got x to the fourth minus y to the fourth. That's the difference of squares, and we can factor that, right? So that's what we did in the next step. We ended up with x squared plus y squared, x squared minus y squared. Now we know that we can factor x squared minus y squared. Yes, Tara?
Why couldn't we do this on any of the other problems?
Do what?
Like, when it
Factor it
has,
this many times?
yeah, why couldn't we do it on the other problems? There were other subtraction ones.
Like what?
Two? Yeah.
So,
Or two.
y minus 2?
Yeah, like,
That's a
if,
binomial, right?
okay,
So we look for a difference of squares. Is y squared? No, so we can't. And when we get to the backside,
I'll just listen to you.
yeah, so when we get to the backside, the subtraction ones we have,
Are we gonna have to do any, like, number 6, anything like it on our assignment? Okay, I'm not.
right, Mara?
Sorry.
Alright, so the reason why we had to keep factoring is because we kept getting factors that fit one of our testing methods. It was a binomial that had a different squares, so we had to factor it. Okay?
Yeah.
Anyone have any questions?
Is this all,
That's actually a really good
is
question.
this all
You're
that's gonna be on homework?
Yep.
Follow these exactly?
Yep.
Um,
Alright, so, before I let you guys go on your homework, what's the first thing you always check for?
GCF.
GCF. After that, what's the next thing you check for?
Difference of squares.
Okay, no, not always.
No, if it's polynomial yeah, that.
You check for what kind of polynomial it is. Based on what it is, you use one of the methods on the front side of the notes.
That's my question.